This is section 6.4. It's a general approach to factoring. All this chapter is all the different kinds of factoring you've learned mixed up together. Because the hardest part of factoring is learning which method to use at what time. So we're just going to work through these problems. We're going to get them factored as much as possible. And then we should be good. Okay. So let's factor 10r squared plus 13r minus 3. The first thing we want to do is we want to look for a greatest common factor if we have one. There's nothing that divides evenly into all of these, so there's no GCF. All right, I do not have 4 terms. I do not have 2 terms. I have 3 terms. Do I have perfect squares on the ends? Well, 10's not a perfect square, nor is 3. So then we have to go to one of the methods in 6.2. Okay, in 6.2, when we had a number in the front, what we did was we multiplied these two things together. And we look for two numbers that multiply to, in this case, negative 30. And we want them to add to 13. This is actually a tricky combination of numbers because if you're not careful with your signs, it looks like there are 2 possibilities. I'm going to list things that multiply to 30. 1 and 30, 2, 15, 3, 10, 4 does not work, and then you have 5 and 6. Okay, if I'm not paying attention to my signs, I could get a 13 from here, doing 15 minus 2. I could get a 13 here, doing 3 plus 10. But only one combination will work for your signs. We're supposed to multiply to a negative number. That means we need a positive and a negative. We're supposed to add to a positive number, so one of these needs to be negative. If I make this a negative 3, that gives me a positive 7 here. This is the only one that works with these signs. So we rewrite this problem as 10r squared minus 2r plus 15r minus 3. And now we can group. From the first grouping, we can factor out a 2 and an r, leaving 5r minus 1. And then from the second group, we can factor out a 3, leaving 5r minus 1. Now I have 5r minus 1 in both of them. So I write it down once, and then I have 2r plus 3 left. Double check that nothing factors further. I don't have a GCF in either one of these. There's no exponent on my variable anymore, so this is my answer. Okay, let's factor x cubed plus 1,000. First thing, do we have a GCF? And the answer is no. There's no variable here, there's no number here, no GCF. Okay, we do not have 4 terms, we have 2 terms. Is there a plus sign in the middle? Yes, so we're looking for a sum of cubes. If it's not a sum of cubes, we don't know how to solve this. Okay, so is x cubed a perfect cube? Yes, absolutely. Its cube root would be x. 1,000. 1,000 is 10 cubed. So its cube root is 10. This is what I'm going to use for my A. This is what I'm going to use for my B. Okay, sum of cubes. It's A plus B first. So x plus 10 times A squared, so x squared, minus A times B, so that's going to be 10x, plus B squared. 10 squared is 100. And that will be your answer. Okay, let's look at 9m squared minus 45m plus 18m cubed. Our first step is always to look for a GCF. Every number here is divisible by 9, and I have at least one m in every one of them. So I can factor out a 9 and an m. Let's see where we get. That gives me m minus 5 plus 2m squared. Now I'm going to rearrange this. Okay, now this might be my answer. I was able to factor out something, so this thing is not going to be prime. What I need to check is to see if this factors any further at all. This would be a trinomial with no GCF. I do not have squares on the ends. So I'd be looking for two numbers that multiply to a negative 10 and add to a 1. The only things that multiply to a 10 are 1 and 10 and 2 and 5, and there's no way to get a 1 out of either of those. So what we've just found is that this does not factor any further. This whole thing is my answer. If this did factor further, I would definitely need to do that. So this is your answer. Okay, so let's try 56x cubed minus 875. Okay, well, I noticed that I have two terms with a minus sign. I see a cube here. So initially, I'm thinking difference of cubes. Okay, the problem is that 56 is not a perfect cube, nor is 875. So we probably have a GCF here. I think I mentioned this before, but if you're curious to see if something has a GCF, just if it exists, you can make a fraction out of these numbers, and then once you enter it in the calculator, if it reduces, then there is a GCF. This reduces to 8 over 125. So if I take this 56, how do I get to an 8? 56 divided by 7 is 8, and I'm betting 875 divided by 7 is 125. So that tells me I can factor out a 7. It's going to give me 8x cubed, and let's make sure 875 divided by 7 is 125, so that's correct. So minus 125. Now, we've done something, so even if this doesn't go any further, this thing is not going to be prime. Now, what I'm hoping for, since I have a minus sign and I have a cube here, I'm hoping I have a difference of cubes. And I do. 8 is a perfect cube. Its cube root is 2. So the cube root of this whole thing would be 2x, and this whole thing is going to be my a. The cube root of 125 is a 5. So 5 is going to be my b. And then I still have the 7. We cannot lose it. So bring down the 7 times. The formula for a difference of cubes is a minus b. So 2x minus 5 times a squared 4x squared plus a times b. 2x times 5 would be 10x plus b squared. 5 squared is 25. So this would be your entire answer. Okay, so let's try to factor 9x squared plus 12x plus 4. First thing I look for is a GCF, and I don't have one. There's nothing that divides evenly into both 9 and 4, and not all of these have a variable. So no GCF. All right, so I checked for a GCF. I have 3 terms, so I'm going to get sent down here. Okay, do we have perfect squares on the ends? Well, yes. 9x squared is a perfect square. Its square root would be 3x. 4 is a perfect square. Its square root would be 2. Okay, so since we have squares on the end, it is worth checking to see if we have a perfect square trinomial. So we asked if we had perfect squares on the end. We're told to multiply the square roots of those numbers and then double them. Do you get the middle term? If I multiply these two things together, I get 6x. And then if I double that, I get 12x. And 12x is the same as 12x. So since they matched up, I have a perfect square trinomial. If they did not match up, then I would have to multiply the 9 times the 4 to get a 36, look for numbers that multiply to 36, add to 12, and so on. It works, but it's much longer. This is going to factor as, Okay, we fit this pattern right here with a plus sign here. So this is a plus b, 3x plus 2 squared. Okay,